So let's continue after that video, which I hope you enjoyed. So the concept of equilibrium involves us thinking of equilibrium as the reaction continuing to carry on. So we call this dynamic equilibrium. So we may have got to a situation where the forward reaction and the backward reaction have the same rate, and the concentration of products is constant and the concentration of reactants is constant, but the reaction has not stopped. It's really important to think about that. The reaction has not stopped because the forward reaction is still going on, the backward reaction is still going on, so we call it dynamic, still proceeding. Now, ways in which we know we've reached equilibrium will be by observing macroscopic properties. So these might be the colour, the pH, the temperature, or the gas pressure. Gas pressure, a bit difficult for us to do in the classroom, but colour, pH and temperature are all properties that we can observe very easily. So the example of the N2O4, so the N2O4 in equilibrium with NO2 reaction. So this system is very well known and very useful because NO2 is a brown gas, whereas N2O4 is colourless. And we can see in the pictures on this slide that initially we might start out with 100% N2O4 and the mixture inside the reaction vessel is colourless. But as we continue on, the mixture gets darker, a darker brown, not just darker, you must say a darker brown, as more NO2 is being formed, until after apparently only 8 seconds, we get this dark brown colour, and still at 3 hours, we've got the same dark brown colour. So the reaction has reached equilibrium. Now, a bit of terminology. Homogeneous equilibria have the reactants and products in the same state. So they might be gaseous, they might be in aqueous solution, dissolved in water, in other words, or they might be liquid. Organic reactions often are homogeneous equilibria. The opposite of a homogeneous equilibria is a heterogeneous equilibrium, and that's when you might have a solid in an aqueous solution. We only have to know about homogeneous equilibria in this course. Another bit of terminology that's really important for you to be comfortable with is the term extent of reaction. And so this is our way of expressing how much or the relative amounts of the reactants and products present. So to what extent the products have been successfully produced. So if we talk about a great extent of reaction, that means we have more products present. If we say the equilibrium lies to the right, that also means there's more products present. So a lot of terminology comes in here. So it has occurred to a greater extent, means that there's more products. The equilibrium lies to the right, we've made more products. And the extent of the reaction completely depends on the reaction, and it can also depend on the temperature and a factor known as the equilibrium constant, which we will learn about in the next section. So here's an exam question from 2008, and we've got an equilibrium between phosphorus 5 chloride, PCl5, and PCl3 together with Cl2. And we're told that some gaseous PCl5 is placed in an empty container. When equilibrium is reached, the mass of the gas mixture compared to the initial mass is. Now, the equilibrium has made products. There is no loss of products here. It's in an empty container, so we've got to assume it's a closed container. So basically we're looking at the law of conservation of mass here. It's not really even an equilibrium question. It's just a, do you realize that when reactants turn into products, nothing is lost? So the answer to this one is B. Second question, when 2-propanol, now I know we haven't done organic chem yet, but you've got equations that show you the formulas, and maybe you'll remember that 2-propanol or propan-2-ol has 3 carbons and 7 hydrogens and an OH. So it's C3, this one here, C3H8O. So when propan-2-ol reacts to form an equilibrium mixture with propanone and hydrogen, which one of the graphs below best represents how the rates of the forward and backward reactions change over time? So the forward reaction has to start with propanol, and the backward reaction is turning the propanone and the hydrogen into propanol. So we want lots of the reactant present at the beginning. So that means that A and C are out because they're starting with lots of the products at the beginning. So now we're deciding, as always, we've got down to a choice of 2, B or C. And so you've got C3H8O, which is our propan-2-ol, turning into our propanone and hydrogen. Now the difference between B and D is that, remembering the vertical axis has got rate on it, in B the rate of the forward reaction is different to the rate of the backward reaction at equilibrium, whereas in D the rate of the forward reaction is equal to the rate of the backward reaction. So this is our winner. This is the one, because that is our definition of equilibrium. So really, this is just a roundabout way to test whether you know the definition of equilibrium. So there we have it. That's the end of section 8.1. Now you can do the reading and answer questions 1 to 4.